Welcome back to C# Tutorials for Beginners. This is the solution to the final coding challenge. I hope everybody had great success, but if you did not, I encourage you to go back, brush your skills up, and try it again before viewing this video. Before we get started, I just want to mention that our code is going to be different. Please don't let that discourage you. Your code might be better than mine. I just created a single solution to the problem, tried to keep it simple, make it concise, and easy to read for beginners. It's important in programming to remember there's usually more than one correct way to solve a problem. So let's start with our requirements. Our first two requirements were to provide a help function and to provide feedback when an invalid command is issued. To achieve these requirements, we need to do some other things first. We need a way to take user input. We need a way to process that input. Those are called derived requirements, when you have to create additional requirements for yourself when they're not explicitly stated in your formal requirements. So let's start there. I'm going to drop open main. Now I have an initialize function that I start with. We'll get to that in a second. Then I have a while loop based off of a Boolean running. Then I write this greater than character just to let the user know where their cursor is, where their input is going to start. Then we take some input from the user and we process that input. And if for any reason we jump out of our while loop, if our running is ever set to false, then we're going to line down. We're going to tell the user to press any key to exit. We're going to wait for that key, and then our application is going to automatically terminate. Okay, let's take a look at the initialize method. So I have an initialize method that contains creating the directory to store our employees, writing a header, and then automatically loading our employees. And if for some reason we can't create our directory, we are going to set our running to false so we can jump out of our loop up here, and we are going to tell the users what went wrong. Now, of course, at the beginning stages of development, this initialize method didn't exist because all I really needed to do up front was write a header. So let's focus on that for now. All this does is say, hey, welcome to our portal, and then it lets them know how to use their commands. And that's the first real requirement, is being able to type help for commands. So once we are in our loop, we process input every iteration. Now, if we drop open process input, you can see really this is just kind of a router. We take the input, and depending on what it is, we just branch out into different methods. And this lets us keep this very clear to see where we're going depending on what command they issue, and not put all of our logic into one place. So now at this point with our first two requirements, this switch would only contain this help block and our default block, because this is going to print our help, and this is going to print anytime they enter anything that's not one of our defined command cases. So first let's take a look at our print help method, which is very simple. We use an escape character /t to insert a tab. That's just a nice to have to make it a little more visible. And then we just have write lines to tell our users what commands they have available to them. Next up we have our print invalid command, which is our default block. And it does the same thing. It just tells the user their command's not recognized and to type help for available commands. And you can see we used quotes around the word help, so we also had to use an escape sequence to do that as well. Okay, now let's get back to our requirements. We have satisfied the first two. Now we need to add employees to the portal, storing them on the file system with three specific types of employees. So let's go back to our process input method. Now for this, I added a case add so we could add our employee. So now I have a region for adding employees because I have a few helper methods, and those will all be called inside of the add employee method. Now that our scaffolding is set up and the user can call the add command, which calls add employee, we need to step back and make some design decisions. Based on our requirements, we have to write this user to the file system. We also have to be able to load from the file system, and we were given a specific structure to load it into. So we need to base our add command on the fact that we are going to be loading it into a given structure. So we need to actually create this structure first. So our first required class was the abstract class employee, and I made that contain an employee ID, which is going to be my unique identifier for all employees. And then I said, well, all employees are going to have a first and a last name. And then I made an abstract method view, which we'll get to when we get to that requirement. The next requirement was an interface iPageable, which will contain a page method, which we will get to when that requirement comes. After that, we had our three employee types, the first being a doctor, which was an employee and an iPageable, which had a specific speciality. We'll get to these other things again when the requirements come. Then we had a nurse, also employee iPageable, that had a level. And then we had a custodian, which was an employee. So now that we've created the required structure, we can gather the information that we know we're going to need to write to our file system. So our base employee is going to have an ID, a first name, and a last name. So we're going to need those three things at a minimum. But then we know we're creating doctor, nurse, custodian. So we're going to need a way to tell what type of employee it is. So when we read it in, we can read it into the correct structure. Furthermore, if it is a doctor, we know we're going to have to store a specialty. If it is a nurse, we know we're going to have to store a level. So now that I have a good idea of what I need to write, the first design decision I made was to create a single directory called employee files that will live right at the executable level. So if I open folder in File Explorer and we go to our executable, you can see that an employee files folder is where all of my employees are going to live. So now let's drop open our add employee logic. And the next design decision that I made was the first thing I am going to take is an employee ID. That's going to be my unique identifier. And my design decision is that is how I'm going to store these files uniquely in our directory. So I'm going to ask for the employee ID, I'm going to get it from the user, and then I'm going to combine it with our path and name the file the employee ID. So then from there, I can say, hey, if this already exists, then I know I have an employee with a duplicate ID. So if we look in our employee files, for example, if you create an employee with an ID 001, he will be stored as a file called 001, and I use that to where I can check duplicate employees and also manage duplicate files. So if we hop back to our logic, you can see now if someone enters an employee ID, it checks to see if the file exists on our file system. If it does, we warn them and we return. So we don't add the employee, we make them call the add command again. That way we don't accidentally overwrite an employee or cause an exception because something already exists, etc. Once we have a unique employee ID, we get a first and a last name as we usually have done. And then comes the next design decision. As we said before, to load our files, we need to know what type of employee it is. So when we create our employee, we need to be given a valid job title to store so that we can load it. So the way I'm doing this is I'm saying we do not have a valid job title. We have an empty job title. While we don't have a valid job title, we're going to ask the user to give us one, giving it their options. We're going to set job title to whatever the user gives us. Then, if their input matches one of our exact job titles, we know we have a valid job title. Otherwise, we're going to tell them to try again, and we're going to re-ask and reset and do this until they give us something that we know we can use. At this point, we have all of the information that we need to write our file, but before we move on, I want to leave a note here. This code here is absolutely not production ready. We are taking a lot of inputs and we are not validating them well. We are checking to see if the file exists when they give us an ID, but they could give us an empty ID, which could cause more problems. They could also give us an ID that doesn't match a structure that we intended. Chances are we want to enforce an ID pattern, or we want to generate an ID ourselves. First and last name, maybe we want to restrict numbers and special characters and make sure it's not blank. And then job title, they have to match this exactly. Maybe we make it case insensitive. And also, they get stuck in this loop forever. What if they are adding an employee and they get to this point and they realize they don't want to add their employee anymore? There's no way to get out of this loop without exiting the application. So maybe we need to add an exit. If they enter exit here, we can stop our ad. These are just a few examples of what you might do to validate your input. That's why you need to use what's called defensive programming. You need to think like your user. What can your user do to break this? What might stop them from being productive? you might be given a requirement to do something, but generally all of these derived requirements, like the validations and making it work properly, those are going to be on you. So you need to think about how it's going to work. Okay, back on track. Now that we have our job title, I created a switch, and based on what they entered, we are breaking down into further methods. I did this because doctors, nurses, and custodians work differently from each other, and you never know if you might add more unique qualities later, so having their own method can keep them confined and easier to upgrade. Another thing is if we put the logic in here, it could keep growing and growing, and now to add a new employee, we only need to add a 3-line case and a new submethod. So as you can see, I'm passing the basic employee information to each one of my add methods. So let's take a look at add doctor. So add doctor is going to take an ID, a first name, and a last name. Then we're going to ask the user for a specialty because that's what's specific to doctor. We're going to get it. Again, no validations here, so keep that in mind. Then what I did was I built a string array with all of my information. Doctor is the type, ID, first name, last name, specialty, and then I'm calling another method, write employee file, with the employee's ID and the doctor data. So now let's take a peek inside write employee file, which I take an ID and data, and then I combine the employee's file path with the ID. Now, the reason I kept these two as separate parameters is because the ID is serving as the file path. Now, the data contains the ID, but if we ever decided that we wanted our file name to be maybe their last name, comma, first name, or something different, then we would have to change more than just this one parameter. That's why I kept them separate, but there's no need to at this point because you could get the ID out of data. Okay, now we have a try catch, which is going to try to write all lines with our file path and our employee data. So if we look back at our employee files 001 and we open this up, you can see that it's going to write our type, ID, first, last, and specialty line by line because we are calling write all lines. After that, we notify the user that it has added successfully, and then we load employees, which again we'll get to. If this fails, we would jump into our catch. We would never notify success or load. We would say, hey, we could not create the employee file. We would give the exception message, and then we would set running equals false. And then immediately our next iteration of our input in main would exit out and then notify them to press any key to exit. So now let's go back down to our add doctor method. We also need to add a nurse and a custodian. So if we look at add nurse, you'll see it's very similar to add doctor. It only contains the things that are specific to nurses, like getting the level and adding a nurse collection that includes the level. And then we call the exact same write employee file. And if we look at add custodian, same thing. We build the custodian data and we write the employee file. Because we broke these out in separate methods, we are able to use the same write employee file to write any employee, even though they have different data collections. And that allows us to try catch in one place, do our write in one place, and do our other actions in one place without having to copy this code to multiple places. And that saves a lot of time in maintenance and upgrade. Okay, so we have successfully taken input for a new user, and we have added that user to our file system. So let's take another look at our requirements. So next up, we need to be able to remove a specific employee. So we would go into our process input. We need a remove case where we can remove our employee, and then close this region up. We need a remove employee method. So the way I implemented this is I take an ID for an employee to remove. I combine that with our employee's file path because we know our files are the same name as our ID. If the file doesn't exist at our file path, we can notify the user that there is no employee with that ID found. Otherwise, we build our try catch, we try to delete that file, we notify success, and we reload our employees. If we do not have success deleting, we fall into our catch, we notify error deleting employee file with our exception message, and again we set our running to false. Even though adding this delete method is easier than our add method, it needs just as much or more consideration because deleting data is usually more serious than adding it. First major thing you need to be aware of is that you are deleting the correct data. So validating your inputs and where you are looking for that data is extremely important. And the next thing is before you delete, it may be a good idea to prompt the user, are you sure you want to delete this? Okay, one more requirement down, back to our requirements. Load employee data into the system on demand. So again, back to our process input, we need a load case to load our employees, and then we need a load employees method, which I have this region, loading employees. Similar to adding employees, I have them broken down with their individual load methods. So let's jump into load employees. Now up here in the program scope, you'll see that I have a list of employee called employees, and I create a new object immediately. So then when load employees is called, I want to clear that list to make sure it's fresh to load our employees. Next up, I'm opening a try catch in which I'm using the directory class to get all of the files from my path, which is going to give me a string array containing the file paths of all of my employees. Then, for every employee file in my files, I'm going to read all of the lines of that file into its own string array. So if we look back up here at our employee file, by the time we're here, our employee data is going to contain an array with every line from our file, so that we know the first index 0 of our employee data is going to be our type. And from there, I'm going to switch on that type, and depending on the case, I'm going to load that specific employee. Before we move on, I want to give a few more notes about writing good code. We are reading all of the lines out of our file, but then we are assuming that index 0 of our file exists. Well, if this file got cleared out, this would throw an exception. And while we are catching generic exception, we could easily check the length of our array to make sure that this is possible. And if it's not, we could notify the user that there was something wrong with this specific employee's file. Also, if our switch came up with something that wasn't a case we expected, we could have a default case to cover the fact that our file has been corrupted or is unreadable for some reason. So again, while you're programming, try to put yourself in the shoes of your user, try to break your code, and try to make it stronger. Okay, so if any reason our directory or our file class calls fail, we will jump into our catch, error loading employee files with our message and set running to false like we did before. Again, I will mention that it can be worth try catching these separately, and it can also be worth catching the exceptions specifically depending on your use cases to make your program stronger and easier to fix. So now that we have a string array of our data, we can pass it into our specific load functions. So let's jump into load doctor, which you can see it takes a string array of employee data, creates a new doctor object with the indices from our array, and then it adds the doctor to our employees list. Similarly with the nurse, we're going to create a nurse, and with the custodian, we're going to create a custodian. This way we can pass a string array, create the specific case that we need to in a very similar manner, and then add it to a collection that can keep everyone. Similar to the add methods, keeping these separate means that adding a new employee only takes a new case and a new load method specific to that employee, and all of our other logic like this can remain the same. For good measure, since we talked about validating this, let's also talk about validating the rest of the employee data. So we can validate this one generically because it's always going to be the type no matter what employee. But once we get into these separate methods, we should probably validate these fields per employee type to be sure that not only do they exist, but they are what we expect them to be. Okay, now we've completed the requirement to load on demand, we can take this load employees method, and since it clears our employees and reloads them all each time, we can add our load employees methods to things like initialize and add and remove, and we can make it automatically load our employees anytime an action happens that needs them to load. When you find yourself in a project that's missing a requirement that you really think should be there, like automatic loading, you need to ask your stakeholder, your manager, your user, whoever you're doing the work for, if they meant to add that as a requirement. Occasionally, they will have a reason not to want the feature. But a lot of times they will have just forgotten to add the requirement and want to add it. And sometimes it's a lot harder to retrofit a feature when it should have been implemented all along. So when in doubt, just ask. Okay, back on track again. We have implemented load and auto load. Now back to our requirements. We need to be able to view a specific employee. So that takes us back to our abstract class employee, which we're going to have an abstract method view that all of our employees have to implement. Then each one of our employees is going to implement by overriding a view, which is going to have details for our employee, our first and last name. For a doctor, we're going to have a doctor and in parentheses their specialty. So for a nurse, it's going to be very similar except nurse and level. And then for our custodian, it's only going to have their job title. So let's hop back into our program. And of course, in our process input, we're going to need a case for view so we can view our employee. And then in our view employee method, I'm doing a initial check to see if our employees list has anybody in it. If it doesn't, we're just going to say that no employees are loaded and we're not going to do anything else. This practice is called fail fast or fail early, and it's often a great practice because it reduces work on you, your system, and your user. If you know you don't have any employees, why proceed in trying to view one? Next up, we need to ask the user for an employee ID to know which employee to view. And then we need to say we don't have a found ID and look through all of our employees to see if the ID they gave matches any one of our employees. So every employee we have, if the ID matches, we're going to call that employee's view method, and then we're going to say that we found the employee. Then when we're done, if we never found a matching ID, we can alert the user that no employee was found with the ID given. I wrote this section this way so I could make this note. It looks correct and it works correctly, but if you look closely, we go over every employee in our employees collection looking for an ID. We know our ID is unique, so only one employee in our collection can have it. So when we find it, we don't need to look through the rest of our employees. So we could say something like, if found ID, we can break out of our for each. And this can save a lot of time, especially if this collection is huge. On down the line, we will learn an even better way to do this. But for now, I want to show you this so you can be cognizant of optimizing your code. Okay, one more feature down. Next up, we need to be able to page all medical staff, doctors, and nurses. So that's where our iPageable interface comes in. The reason we use an interface here is to share this functionality across some employee types, but not all of them. We need a doctor to be pageable, but we do not need a custodian to be pageable. Likewise, if we created a new employee type, they could be pageable or not pageable. So it's very easy to apply this interface where it needs to be. So now back to program. Once again, our process input will have a case for page, which pages an employee, and then our page employee will fail fast if we do not have any employees loaded. And then for every employee in employees, we are going to page the ones that can be paged. To do that, we check if our employee is iPageable, which currently doctors and nurses are. Then, to be able to access the page method, we need to cast the employee as iPageable, and then from the pageable employee object, we can call page. By using our inheritance, our abstract employee list, our iPageable interface, we have made this so easy to upgrade, because any employee type we add, if we inherit employee and iPageable, the employee is going to get paged without having to add any logic to this method. Okay, we have implemented our page requirement. Now our next requirement is to handle and report application errors due to file system operations, which we handled all along the way. All of those try catches, setting our Boolean running to false, and when we fall out, we press any key to exit, covers this requirement. The last one, use object-oriented principles to ensure further system upgrades will be easily implemented. We have definitely done that. We stuck to our inheritance structure. We used encapsulation to separate our logic out to where it should be. And now if we needed to add an employee type, it would be very simple to do that. And just like that, we have satisfied all of the requirements, we derived our own, and we even created some that improved the application. This application could always be improved further, and that is what you should strive to do. Software engineers always need to be making things better. That is the end of the beginner's course. Thank you so much for watching. Congratulations for finishing it. I hope you had a good time. I hope it was helpful. Please, if you have any questions, feel free to ask. Next up is going to be a WPF series, so we can take the skills we've learned and add user interfaces. So until then, everybody, take care.